Hi, hello guys, this is Vijay, chemistry lecturer from Allahabad Junior College, and as you know that we have started our NEET series. So based on that we are discussing about NEET chemistry some basic concept examiner. So in this video we are going to discuss few more examiner problems. Let us go for the first question. Yes guys, now look at this next question. The empirical formula and the molecular mass of the compound which are CH2O and 180 gram respectively. What will be the molecular formula of the compound? So here are the few options given. So let us see how to solve this problem. So first of all, we should know that the empirical formula. Yes, empirical formula which shows that the number of moles of different elements which are present in a molecule. Okay. So to calculate the molecular formula of the compound, what we supposed to do? Multiply the number of moles with empirical formula. So first we should find the empirical formula, then it should be multiplied with the number of moles, so that we can easily get the molecular formula. Okay. So let us see how to solve this problem. Answer. Okay. So empirical formula mass, let us write. The given compound empirical formula mass, the empirical formula mass, let us write. So what is the compound given here? CH2O. Yes, this is the compound given. Yes, number of the elements present in this compound there are 3 elements: carbon, hydrogen and oxygen. So let us write in detail. So carbon, that is 1 into 12, okay, molecular mass. Then hydrogen, that is 1, so 2 atoms are there, number of atoms plus 1 into 2, plus oxygen, that is 1 into, only 1 atom is there, so 1 into 16. Yes, so simplifying this, we will get the sum of this, we will get around 30. Okay, so 30 is what? The empirical formula mass. This is what? The empirical formula mass. But we are going to find the molecular formula, so that we should know the molecular mass. Okay, so molecular mass, that is molecular mass that is given in the question, that is 180. Yes, molecular mass given in the question, that is 180. Now we are going to find the moles, that is what? N. Okay, so N is equal to molecular mass by empirical formula mass. Molecular mass, what is that? 180 by empirical formula mass, that is what? 30. Okay, so divided by 30. So simplifying this, we will get what? 6. 3 6 are 18. So 6 we will get. Now we are going to find the molecular formula. Yes, molecular formula we are going to find. So molecular formula is equal to, we know the formula, N into empirical formula. N into empirical formula. Yes, we know the formula. Yes. Now what is the value of N? That is 6. So 6 into empirical formula. Empirical formula, we know that it is given in the question, CH2O. This is the compound given. Now multiplying with 6 to all the individual elements present in this compound. Individual elements are there here: carbon, hydrogen and oxygen. So 6 into 1 carbon, that is nothing but C6. 1 into 6. Okay. Similarly, here hydrogen, 2 number of atoms are there. So multiplying with this 2 into 6, that is nothing but hydrogen 12. Okay. Similarly, oxygen, here 1 atom of oxygen is there. 1 into 6, we are going to multiply, that is 6. So what is this? This is the molecular formula of the given compound. So this is the molecular formula, C6H12O6. So by this way we can solve this problem. Let us go for the next question. So now let us go for this next question, that is, if the density of the solution, which is 3.12 gram, the mass of 1.5 ml solution, that should be written in the form of significant figures. So here are 4 different options given. Let us see how to solve. First, we should find the mass, then we will get the value. That value we are going to expressing in the form of significant figures. Let us see how to solve this problem. Okay. So, answer for this question. Density of solution given in the question. Density of the solution given in the question, that is 3.12 gram. Yes. 3.12 gram mole per liter. Okay. Similarly, volume of the solution. Volume of the solution, that is also given in the question. Yes. 1.5 ml. Okay. 1.5 ml. So we have density and we have volume. We know the formula for density. Yes. Density formula is what? Mass by volume. Similarly, mass is equal to volume into density. Yes. We are deriving the formula from density formula. Yes. So density is equal to mass by volume. Then mass is equal to density into volume. We are getting this formula from density. So simple. So mass we are going to find. Mass is equal to volume into density. So volume is given here, density is also given here. So both we are going to multiply. That means 1.5 into 3.12. So simplifying this, what we will get? We will get 4.68 gram. So we are going to find the mass. Yes. So mass we are going to express it in the form of gram or kg. So we here in this case we are going to expressing in the form of gram. That means what? 4.68 gram. Clear? Yes. So by this way we can solve this problem. Now remember that in the question they asked the result, whatever we have got the value, that should be expressed in the form of significant figures. Yes. So this could be written as 4.70. Yes. This could be written as 4.70. So 68 closest to the whole number, that is 70. So in this way we can solve this problem. So we can express it like in the form of this as 4.7. So by this way we can solve this problem. Let us go for the next question. So the next question, that is, which of the following reactions is not correct according to the law of conservation of mass? Okay. So here are 4 different chemical reactions given. So let us see which one is not exactly correct according to the law of conservation of mass. Okay, let us see one by one. See, let us see the direct answer for this question. So answer, yes. So first of all, we know that law of conservation of mass. Law of conservation of mass is nothing but whatever the reactant in the chemical reaction, which is always equal to the product what we are gaining or yielding. Okay. So in a chemical reaction, reactant, whatever reactants are there, that is always equal to the product. So this is what the basic principle of law of conservation of mass. Yes. So according to this, you see in the question option B, if you see option B, that is, let us write the chemical equation first. Yes. Now look at this chemical equation. Yes, the balancing equation. Here C3H8 plus O2, which gives CO2 plus H2O. Okay. So let us balance this equation. The equation could not balance. Yes. Here carbon is 3 in the reactant side, whereas in the product side carbon is 1. Okay. Whereas if you see hydrogen here 8 are there. Yes. So in the reactant side, in the product side, if you see hydrogen is 2 are there. And oxygen here 3 oxygens are there, 2 plus 1 3 here, 2 oxygens are there. It is not balanced. Okay. So in this chemical reaction, if you see, these both are said to be what? Reactant. Reactant A and reactant B. And there are 2 products we are gaining, product A and product B. So reactant A, reactant B, product A and product B, overall product and overall reactant, which is not equal to each other. Yes. In what way it is not equal to each other? Let us see the molecular mass of the individual compound. So here if you see C3H8, so that is nothing but 44 gram. Yes. So carbon is 3, hydrogen is 8, yes, carbon is 3, 3 into 12, 3 into 12 plus hydrogen is 8, yes. So adding that both value we will get 44 gram. Similarly, oxygen here number of atoms are 2, so 2 into 16, 2 into 16, 16 is nothing but 32 gram. Similarly, carbon dioxide here if you see, carbon that is 1, 12 and oxygen 2 are there, 2 into 16, yes, 2 into 16 plus 12, 32 plus 12, 44 gram. Here if you see hydrogen 2 are there and oxygen 1 is there, oxygen is 1, that means nothing but 16, 16 plus 2, hydrogen 2, 18 gram. So in the entire chemical equation you can easily find that the reactant, whatever we have got the mass of the reactant, that is not equal to the mass of the product. So this is what the law of conservation of mass. So based on that, this particular equation is not obeying the law of conservation of mass. That is the reason in this particular question option B is not obeying for the law of conservation of mass. So by this way we can solve this problem. Let us go for the next question. The next question, that is 1 mole of oxygen gas as STP, that is equal to, here are 4 different options given, 6.022 in 10 to the power of 23 molecules of oxygen, 6.022 in 10 to the power of 23 atoms of oxygen, 16 gram of oxygen and 32 gram of oxygen. Let us see how to solve this problem. So answer for this question, 1 mole of, yes, so 1 mole of oxygen gas at STP. So 1 mole of oxygen gas at STP, which is always equal to 6.022 into 10 to the power of 23 molecules. Yes. So if this is not only for oxygen, for any gas which is 1 mole at STP, that value is 6.022 into 10 to the power of 23 molecules. Okay. So 32 gram of oxygen, this also could be expressed as 32 gram of oxygen. Why? Because number of atoms present in oxygen are 2. Yes, molecular mass we know that 16. So 2 into 16, that is nothing but 32 gram molecular mass. Yes, 2 into 16 molecular mass we know. So this is always similar to this. 1 mole of oxygen gas, that is equal to 6.022 in 10 to the power of 23. Otherwise we can express it like 32 gram of oxygen. Yes. Okay. So in this case, if you see the question there are 4 options, among that A and D. These 2 options if you observe, option A that is given as 6.022 into 10 to the power of 23 molecules, option A, and option D which is given as 32 gram of oxygen. Yes. So both are what? Similar to each other. So in that way we can solve this problem. So 1 mole of oxygen gas at STP, which is always equal to 6.022 in 10 to the power of 23 and also 32 gram of oxygen. So by this way we can solve this problem. Let us go for the next question. Look at this next question, that is, which of the following pairs which have the same number of atoms, 16 gram of oxygen and 4 gram of hydrogen. So both are in the state of gas. 16 gram of oxygen and 44 gram of carbon dioxide. And next one is 28 gram of nitrogen and 32 gram of oxygen. Okay. And finally 16 gram of carbon and 23 gram of sodium. So both are in the state of solid. Okay. So now let us see which 2 pairs are having the same number of atoms. Okay. So let us see how to solve this problem. So answer for this question. If you look at this question particularly, option C and option D. So both these options are having the same number of atoms. Let us see how it is possible. Okay. So number of atoms in option C, if you see, option C and option D. Option C, what is given? 28 gram of nitrogen and 32 gram of oxygen. Yes, this is given in the option C. Okay. First let us complete this option C, then we will go for option D. Number of atoms present in 28 gram of nitrogen. Okay, number of atoms present in 28 gram of nitrogen. Okay, so number of atoms present in 28 gram of nitrogen, that is nothing but 28 by 28, because number of atoms present in the nitrogen are 2. Yes, so number of atoms present in 28 gram of nitrogen, that is 28 by 28 into, we are going to multiply this with Avogadro number. Yes, Na into 2. Na is nothing but 6.022 10 to the power of 23 number. 6.022 in 10 to the power of 23. That is what Avogadro number. Okay. Yes. So the sum of this, what we will get? 2Na. Na is nothing but Avogadro number. Yes. So number of atoms we are getting in 28 gram of nitrogen, that is number 2. Similarly, number of atoms present in the second category, that is 32 gram of oxygen. Okay. Yes. So for this, again we are writing the same method like this, 32 by 32 into Na into 2, that is the product of this sum, what we will get? This also will get 2Na. 2, why we are getting? Number of atoms in oxygen present are 2. Number of atoms present in nitrogen are 2. So both are having the value similar, no, same. Number of atoms are 2 here, 2 into Avogadro number. Here also 2 into Avogadro number. So by looking these two sum of the number of atoms of nitrogen and oxygen, we are getting similar. That is why option C, which has same number of atoms. These pairs have same number of atoms. Similarly, option D, let us see. In option D, what is given? Carbon. Yes. So carbon, that is there 12 gram. 12 gram of carbon. And one more pair of this case, 23 gram of sodium. Okay. So 12 gram of carbon, 23 gram of sodium. Okay. So 12 gram of carbon, 12 gram of carbon contains number of atoms for carbon, that is 12 by 12. Yes, into Na into 2, that is nothing but 2 into Na, cancelling this. Yes, 2 into Avogadro number. Similarly, in this the second category, you see 23 gram of sodium, that is also 23 by 23 into Avogadro number into 2. Cancelling this, what we will get? 2 into Na, Avogadro number. Yes. So in this case also, you see the sum of number of atoms present in 12 gram of carbon, 23 gram of sodium. So both are same, 2Na. Yes. Yes. So option C and option D both are having the same value. So here the two pairs which are having the same number of atoms. So by this way we can solve this problem. Let us go for the next question. Now look at this next question, that is, which of the following solutions have the same concentration? 4 different options are given. 20 gram of sodium hydroxide in 200 ml of solution, 0.5 mole of KCl, potassium chloride in 200 ml of solution, 40 gram of sodium hydroxide in 100 ml of solution, 20 gram of potassium hydroxide in 200 ml of solution. So 4 different options are given. Let us see which two are having the same concentration. Concentration is nothing but, we know the formula, that is molarity. Okay. So let us see. answer for this question. If you look at this, all the four options, option A and B both are having the same concentration, same molarity. Let us see how it is possible. Okay. So concentration is nothing but molarity. Molarity. You know the formula molarity. Yes, M, capital M. So molarity is equal to weight of the sodium hydroxide into 1000 by molecular weight of the sodium hydroxide given in the volume given in ml. Okay. So weight of sodium hydroxide, here we are considering for sodium hydroxide. Weight of any solute here we will consider when we are doing for any other compound. Here we are considering for sodium hydroxide. Weight of sodium hydroxide into 1000 divided by, yes, molecular weight of sodium hydroxide. Molecular weight of NaOH into volume given in ml. Volume given in ml. Okay. So weight of sodium hydroxide. Sodium hydroxide weight. Let us see. So in the option A, 20 gram of sodium hydroxide present in 200 ml of solution given in the question. So weight of the sodium hydroxide is there in the question. 20 gram is nothing but weight of the sodium hydroxide into 1000 divided by molecular weight of NaOH. NaOH molecular weight. So sodium, here in the compound 3 elements are there, sodium, oxygen and hydrogen. Hydrogen 1, oxygen 16 and this sodium 23. Adding this all we will get the molecular weight. So molecular weight we are getting what? 40 into volume given in ml. Volume what is given? 20 gram of sodium hydroxide which is there in 200 ml of solution given in the question. So 200. Okay. So simplifying this we will get 2.5 M. M stands for molarity. That is nothing but concentration. Concentration of the solution. Okay. So simplifying this we are getting 2.5 molarity. This is what? Option A. Similarly, if you see option B, yes, option B, option A which has 2.5 molarity answer. Okay. So option B, let us see. In option B also applying the same formula, molarity is equal to M, weight of the sodium hydroxide into 1000 by, in option B that is given, not given as sodium hydroxide, right? In option B it is given KCl, potassium chloride. Okay. So weight of the potassium chloride into 1000 by molecular weight of potassium chloride into volume given in ml. Okay. So molarity for option B we are going to consider. So here the weight of the KCl given in the question, that is 0.5 mole into 1000. Same formula we are following. Molecular weight of KCl. Yes. So molecular weight into that is present in 200 ml of the solution. So both we are going to write. Yes. So that is 200. So simplifying this. Yes, 2 zeros cancel and 10 by 2 5. So 5 into 0.5. We will get the answer 2.5 M molarity. So option B also we are getting 2.5 M. So these two options are having same number of molarity, I mean concentration of the solution. Yes. So by this way we can solve this problem. Yes children, so far we have discussed about this NEET chemistry some basic concept chapter, examplar problems. This will be continued with one more video. Until then, thank you guys.